Okay, now we continue with example 2. Find limit x to infinity ln x bracket squared over e the power of 2x. Okay, this example actually in page 12 chapter 2 in your handout. Okay. And for this example, if we use direct substitution, we will have infinity over infinity, which is under type 2. Okay, because if we substitute infinity into variable x in numerator, we have infinity. And if we substitute infinity into denominator here, we also have infinity. Okay, so this is under indeterminate form. Okay, to evaluate limit in indeterminate form, we need to use L'Hopital rules. Okay. Okay, when we use L'Hopital rules, we need to differentiate numerator and differentiate denominator. Okay, differentiate one by one. Okay, never use quotient rule because we want to evaluate limit. Okay, not differentiate with respect to x. Okay. Okay, so how to differentiate ln x bracket squared? Okay, we can use generalized power rule. Okay, when we use generalized power rule, what we do is we move power to the front here and then we copy in bracket ln x and then the power must reduce 1. So 2 minus 1. So we have 1 here. No need to write the power of 1. And then we differentiate in bracket. In bracket is ln function. So when we differentiate ln x, the answer is 1 over x. Okay. And then we differentiate denominator. Okay. We can use exponential rule to differentiate e the power of 2x. When we differentiate e the power of 2x, first step we just copy e the power of 2x and then we differentiate power. Means that we differentiate 2x. So we have 2 here. Okay. Okay, and then we have fraction in fraction here. So we can simplify. Times 1 over x here means that the whole fraction we can write like this. Okay. Okay, after that we can simplify 2 from numerator and 2 from denominator. Okay. Okay, and then after that we have numerator with ln x and denominator with x e the power of 2x. And after that we can try to use direct substitution. But if we use direct substitution, the answer still get infinity over infinity because when we substitute infinity into variable x here, so we have ln infinity which is equals to infinity, and when we substitute infinity here, so we still have infinity in denominator. So means that the answer when we use direct substitution gives the infinity over infinity, which is indeterminate form. So to evaluate limit in indeterminate form, we need to use L'Hopital rule. Okay. And again, when we use L'Hopital rule, okay, we need to differentiate numerator and differentiate denominator. Okay. As long as the previous application of L'Hopital rules produce an indeterminate form, it is okay to repeat it as many times as necessary to reduce the limit to a form that can be evaluated. Okay. Okay. And then we differentiate numerator. So we have 1 over x. Okay. We differentiate ln x. So we have 1 over x. Okay. And then we differentiate x e to x. This is multiplication operation. Okay. So we need to use product rule to differentiate. Okay. So our u is x and our v is e to x. We can use product rule, but we never use quotient rule. Okay. Okay. So in L'Hopital rule, we can use product rule. Okay. Okay, and then, but first step, the function should be in terms of fraction first. Okay. Okay, so now to differentiate x, e the power of 2x, our u is x, our v is e the power of 2x. Then we differentiate x, it becomes 1, and when we differentiate e to x, we can use exponential rule, so the answer is e to x times 2. 2 here comes from derivative of 2x. Okay. Okay, after that, we substitute into product rule formula, vu prime. So we multiply this, so we have e to x. And then times uv prime, we multiply this, so we have 2x e to x. Okay. And after that, we have fraction in fraction. So we can simplify. Okay. X from numerator here. Okay. X from denominator in numerator here. In fraction here, we can move down. Okay. And after that, we can try to use direct substitution. Okay, if we use direct substitution, we have 1 in numerator. And in denominator, we substitute infinity into variable x. Okay, so we have infinity. Okay, so after we use direct substitution, the answer is 1 over infinity. No more infinity over infinity. Okay, we cannot have infinity over infinity when we evaluate limit. Okay, but we can have 1 over infinity because 1 over infinity equals to 0 under limit topic. Okay, the analogy is like, let's say if we have 1, so we divide by any big value. So the answer approach to 0. Okay, this is what you learn in calculus 1. Okay, so the final answer is 0. You can check your answer using symbol lab. Okay, so you use the syntax exactly to the given question. Okay, ln limit x to infinity, and then ln in bracket x bracket squared over e the power of 2x. Then we just press go or press enter. Okay, and then the answer will appear like this. This is the final answer 0, and this is the steps. Okay, and the final answer is 0. Okay, like this. Okay. Coming up next, examples for type 3, which is 0 times plus minus infinity using L'Hopital rules. Thank you for watching. Stay tuned. Bye. Assalamualaikum.